24. In this question, we need to represent this condition. So let me just, my laptop, right. All right. So the year born for the employee who was born the earliest in the company. Yeah, we need to represent, although it's not a very hard, we only need to represent the earliest born year, the earliest born year in the company. Yeah. So there are two ways we can do that. Yeah. The first one, we use the order by. Yeah. Order by. We can sort it. Order by B date, right? Birthday. B date. In ascending order. The default is the ascending order. The first one in the ordered born years, that's the earliest. Earliest is the first one. After you sort it in ascending order, the first record is the earliest. Yeah. So based on that, you can use the limit keyword. Limit 1. That means the first one. We know limit, usually we use two numbers, right? Yeah. The first one tells you the starting point. Then the second one tells you how many records, rows we select. But here we can only use one, this version, the same as limit. The first one is 0, second one is 1. Because when the first number is 0, we can omit it. The default case, the first parameter of the limit clause, 0. Okay, yeah, 0. Yeah. That is the first method. Second one, earliest, we know that's the smallest birth year birth. Yeah, look at that. All right, so here, first, we can use the year function. Year of B date, right? Year function. Because B date, oh sorry, B, birthday, that regular date number, we have year, month, day. Here we just take the year part. That's the year function. All right. But we want to have the smallest year number. Yeah. To get that smallest, we use the minimum function, min. Min function. Year. B date. Look at that. Okay. Minimum function, year function. All right. Yeah. But how do you select that employee? Right. So for the employee to be selected, it's year function. Look at that. It's year function of that employee's birthday equals that minimum. How about that? How about that? That's another way to represent this condition. Look at that. Okay, yeah. Yeah. So you can think about, different ways. Yeah, different ways. Yeah. These two commonly used ways. Yeah. The first way, because you use the limit keyword. Limit keyword, that means this is a MySQL version. When you change to a different DBMS, you may not be able to use this way, limit way. Then the second way, although it is a little harder than the first way, but the second way, you can use it in other DBMSs. Yeah. All right. You can play around. Yeah. So for number 24, yeah. Try different logic in this question. Yeah. Then you figure out which one works for you. Okay. Yeah. Probably one works better than the other. Yeah. All right. Number 25, the last question. This one, list first name, last name of each employee who has, the first condition, who has more than 2 dependents. First condition. Second condition, who is making more than 50,000. Yeah. The second condition easier. If you represent the second condition, it will be easier, right? Yeah. Erase. Yeah. The first condition, not very hard, but the format, here I just explained when you apply that format, special format. There is one way you can use. Yeah. Here we count the number of dependents. That means we use the count function. Count function. Count the number of dependents. Okay. We have a dependent table. In a dependent table, so you can count. Given an employee, you have the ESSN number, right? ESSN. With the ESSN, you can count the number of dependents. Yeah. And that part, you have a select statement, right? Select. Then count function. All right. Then probably ESN. Yeah. 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 Count from. All right. So the remaining part, I think you can write. All right. This whole select statement, it returns number of dependent. For this employee. Okay, so that's a number. Now we want to have more than 2. So that means this number should be greater than 2. Okay. Now you treat this whole thing as your first condition. Because this is a Boolean statement, greater than 2, true or false. So this is a Boolean expression. So you get a true or false. Okay, all right. Then your second condition, that's very easy. Second condition. Right. So you combine these two conditions, that's your whole condition. Okay, and the first condition and the second condition. Okay, where first condition and the second condition. Okay, yeah. So then it should not be too hard. Yeah. All right. So after I give you the hints here, hopefully, yeah, you need to use your understanding. Yeah. The hints only work when you have some good understanding. Yeah. Because for some students, I know this from other classes, some students, even I give a lot of hints, they cannot use them because they do not understand. They do not have the idea. Okay? Yeah. So here, only when you follow this class closely, you have the background, you understand what I'm talking about here, yeah, then you can follow the suggestions in my hints. Yeah. All right. The last thing, before I move to the next topic, last thing, let's go back to the question 15. Any students still have question in this question? Yeah, I explained the last time. I spent a lot of time last time. So today, the last chance, if you have some doubt, you can ask me so I can explain a little more. Yeah. So if it is clear, the meaning of this question, clear to you or not. Yeah. All right. Because the video is available. So if you want to watch that part, so you can go to that video, yeah, watch that part. Yeah. If no question, let us move to the next topic. I want to explain our project a little bit. Yeah. The hardest part in the project, editing a row. Editing a row. Yeah. Yeah. Let me just give you some information. Yeah. Here, I take the screenshot of that feature, edit button, this feature. Yeah. Other features, I think, relatively easier for you. Okay, yeah. But this one, a little harder. Yeah. The reason is this. All right. So the reason is we have, in this table, we have 5 columns. Right? All right. 3 column, yeah, with primary key. 2 columns without primary keys. The question is how to identify a row without primary key. Okay. For the second case. The first case, because we associate the first case. For each edit button, we associated with the primary key, right? So you can use that primary key to identify that row. Okay, yeah. But for the second case, there is no primary key. So how do you identify that row? We need to solve that special case. If we can solve this technical problem, then I think the whole project should not be that hard for you. Yeah, because we have the starting point, the three case study examples I gave you. That's your starting point. You just work on it, okay? Adding some basic features. But this part, yeah, let me talk about the idea a little bit. Yeah. Let me bring up the table definition first. This is the table definition. 5 tables. All right. Here, I only want to look at those 2 tables without primary keys. Yeah. At the end, we can see course table, section table, and a student table. These 3 tables have the primary keys. So we don't worry about these 3 tables. Okay. For the remaining 2, what are the remaining two tables? One is the prerequisite table. The second one is that grade underscore report table. Grade underscore report. Prerequisite. These 2 tables do not have the primary keys. All right. Next question. How do we identify? So to identify, here we can only use the values of the columns in each row. Yeah. So you can see, yeah, how to identify. To identify, use the values of certain number of columns to identify. Okay, for this question. Okay, now, so let's look at this table here. First, for prerequisite, we only have 2 columns. To identify a row, you need to use both values, course number value and a prerequisite underscore number value. These 2 values. Yeah. You can see, yeah, with these 2 values, you can identify a row. All right, yeah, okay, yeah. For the grade report table, there are, several columns, 1, 2, 3, 4, 5, but what is the minimum number of columns we need to identify? Smallest number of column values we need to identify a row. 2, still 2. Yeah. So look at the data here, grade report. Yeah. If we use the student number and the section identifier number, we can identify, right? Because the remaining data, just information associated to these two numbers. You can see if we just use the student number, section identifier number, these two, we can identify all the rows. Okay, so we can do editing, and the operations. Okay, yeah. All right. So with that information, now let's go back. Yeah. Another level of detail I'd like to talk about. Okay. Yeah. Then for the primary key, yeah. First, let me talk about the primary key case. Yeah. First, primary key case. Yeah. And when you click edit button, you need to get a value for all the columns, right? Yeah. For the primary key case, because you have the primary key, right? So, and there is two ways you can use. All right. The first way, send a request with the primary key as the parameter. And the server returns the result and with the values you want to edit. Okay, yeah. When they send it back, that row value should be treated differently. Okay, yeah. Special treatment, yeah, here. All right. The second is use this Ajax technology. Yeah. Some of you may not be familiar with this Ajax, and some other student probably has some experience using this Ajax. Ajax, that means you can use a JavaScript function to get the data of that column or at that row of that selected row, right? Because you have the primary key of that row directly. Okay, Ajax. Yeah, if you know Ajax technology, so then you can use it here. Okay, yeah. For those who are not familiar with Ajax, yeah, I think at some time I can give you a simple example. I can explain that Ajax technology and show you a simple example. If you feel comfortable, you can use this method. because this method, it will be faster. It will be faster. Yeah. So, and this method, there is another technology that supports this method, jQuery. For some students, if you like to use the jQuery technology and Ajax together, jQuery has good Ajax support. So you can write very little code, you can do the job using Ajax technology. Okay, yeah. But if you know it, then it's a good chance to apply it. If not, if I have a chance, I may show you some example. I can explain these two technologies to you. If you feel comfortable, you can use. Okay. If not, then you just use the older way, traditional way. That request. Yeah, that's a one normal request, HTTP request. Send it to the server directly. All right. So that's for the primary key case. For the non-primary key case, all right. Non-primary key case, because you cannot send primary key to the back end, right? Yeah. Here, I feel non-primary key case. Let me use space here. I need a little more space. Okay, yeah. Use a JavaScript function to get the values two column values, right? Those two special columns to get the values from the client side. Okay. Yeah. JavaScript function, so we can get a value from the client side. But to make this step work, we need to make these values available for the JavaScript function. We need to do preparation. We need to make them available. How about that? Okay. That's the idea. So here you can see, in order to make these things work, you need to have background of these things. Think about that. If you need further help, so here I give you an idea. Today, I just give you ideas. If you need further help, then I can give you a code example. I show you some code example to do these things. I feel for some of the students, probably you need my code examples. Okay, yeah. For each feature, I write some short code. Okay, yeah. So if you understand the meaning of my code, then you can modify it. Oh, yeah, yeah. All right. Hmm? Yep. Oh, okay. Yeah. All right. Okay. Yeah. All right. So that's this project. Okay. Yeah. Any question, just let me know. Yeah. Because from now on, other than preparing for midterm final, we need to work on the projects. Yeah. And there is a lot of work, but I need to help you get through all these things. For the remaining of the semester, I need to help you get through all these things, especially these two programming projects. Everyone has to complete these two programming projects. You just ask me questions, so I can give you sufficient information you need to complete these two programming projects. Okay, yeah. That's very important for this class. Okay. All right. Now, first, today I give you this information first. I don't know if you can digest or not. Yeah. So if not, then next time I will give you more background. I will explain more how to apply these technologies. Okay. Yeah. All right. Yeah. But with the help, you really need to complete these two projects. Yeah. The second project, I will assign you in about next week after the midterm. I will assign you a second project. Okay. Yeah. All right. Next, I need to complete the remaining part of part A of module 5. We did primary index. So let me go back to this concept and explain the details of this concept. Yeah. All right. We are here. Yeah. So we are here, right? Yeah. But let me just repeat the whole thing. All right. Our goal, we want to organize our data to support fast search. Okay, so here, what we are doing? Yeah. Our goal here for fast search operation. How to do that? We apply technology using auxiliary files, secondary supporting files. That's the indexing technology. Okay, so using secondary supporting files. Yeah. What's the structure of supporting files? All right. Yeah. An ordered file. All right. whose records are of fixed length, this property, fixed length, with two fields. The first field is a key, and the second field is a pointer. All right, so that's the structure of our supporting files, index files. All right. There are several types of index files. The first one, the easiest but most commonly used index files is called a primary index. Here, let's look at the structure of the primary index. The primary index, there is a key part and the pointer part. The key part we call the primary key. Okay, primary key, the key part of the primary index. So this primary key is different from our regular primary key, our usual primary key. That primary key, the meaning is different from this primary key. All right. Yeah. Do not get confused. Okay. Yeah. Two different meanings. For the primary key. All right. The first field, that first field, the key field, that's the primary key of the primary index, is of the same data type, all right, as the ordering key, ordering key field of the data file. Yeah. Because you organize your data based on certain ordering key field with respect to certain ordering key field. Okay. Yeah. So then that key field, you use it as the primary key field for the primary index. Okay. Yeah. Next, the second field is a pointer to a disk block. So here we have this concept, disk block. We know on the hard disk, hard disk, look at the, cylinder, right? Hard disk, usually we organize as a cylinder. There are many slices of disks. Hard drive, okay? So many disks, all right? Many, So here we talk about one disk. It's like that. Then the data stored in sectors. Look at that, sectors, okay? Yeah. And, all right. This is a sector, all right? Sector, all right? Yeah, like that. Yeah, all right. Then there is a unit disk block unit. Okay, yeah. Disk block unit. Okay, yeah. When we load data from hard disk to memory, we want to load appropriate amount of data. Okay, so each time we load one block, okay, that unit, okay, load one block of data. Block. Each time we load one block of data. okay, to the main memory. Yeah. We cannot load one record because one record, we know one trip from hard disk to main memory is very expensive. If one expensive trip, you only load one record, then it's not efficient. So we want to load multiple records in one disk block. Okay, yeah, or one page sometimes. Yeah, one disk block. Yeah. All right, so that's why here we have this disk block concept that contains the record to be searched for. Yeah. But that disk block usually contains quite some. Okay, yeah. It depends how large is your record. If your record, the size is relatively large, then you can store fewer number of records in one disk block. If relatively small, then you may have relatively large number of records in one disk block. Yeah. All right. But the whole block is loaded into the main memory. Then inside the main memory, then you search for the record. Okay. Yeah. So you search the record in main memory in the block. Okay. And that search is sequential search, linear search, not binary search. Because the data is not ordered. Look at that. That disk block, inside that disk block, the records in that disk block is not ordered. So you cannot apply binary search. Yeah. Yeah. Here, it could be a little confusing. Yeah. So we need to understand these things a few times. Yeah. In today, you cannot completely understand. Yeah. We need to get to this concept several times. Yeah. All right. Linear search, not ordered. Yeah. Inside the index file, it's ordered, but in this place, not ordered. It's not indexed. Yeah. Look at that. This disk block, that's the original data. Original data, not indexed secondary data, not index supporting data. It's the original data. In the original data, the data is not ordered, right? So you cannot apply binary search on original data directly. You can only apply linear search only for the index file. Secondary data, it is ordered, and then you can apply binary search. Okay, yeah, here, that's the point. All right, then number of index entries. All right, there is one index entry in the primary index file for each block in the data file. That's the main feature. So this one is the main property of the primary index. Okay, all right. Each entry, each index entry, that's the key pointer pair. Key pointer pair only points to one block. one whole block. Okay, that kind of one-to-one correspondence. Yeah. I will explain in the next slide. I draw a diagram to explain that. Yeah. It's called an anchor record in the primary index. Yeah. So let me explain this concept, anchor record in the primary index. Let's understand this part well. Each index entry has the value of the primary key field for the first record in the block, disk block. Yeah. Here I need to draw diagram to show you. Yeah. Because I will not draw that cylinder way, that disk shape, because that way it's very hard to draw. Here I just draw, you know, some abstract way. All right. Suppose this is the hard disk. All right. Okay. And we store data block by block. So each box, so I treat it as block. Okay. Yeah. All right. We know we have sequence of block. We know they organize in the, you know, cylinder, disk way, you know, circular sector that way. But when I draw here, I just arrange in the that way. All right. Yeah. To understand. Then primary index structure, index file. So let's consider one primary index file. Okay. All right. We know a sequence of entries. Yeah. Okay. Yeah. Each row, one entry. Okay. Key, comma, pointer. Okay. Yeah. K1, P1. How about that? K2, P2, and so on. Okay. All right. Kn, Pn. All right. That's the primary index file. All right. Then K1, P1, this entry points to the first record in this block. We call it this anchor record. Because the first record can tell us where to start for each block. So it's an anchor record. All right. So K2P2 point to the first anchor record of the second disk block, and so on. Okay. The last one point to, you know, yeah, anchor record. Here you can see for, yeah, this is the original file. All right. This part, this is the original file. Original data file. Yeah. All right. In the original data file, one whole disk block, we only need one small primary index entry to point its location, to tell us the location in the hard disk. Think about that. That's a big compression, right? Yeah. We have large amount of data in the original data file, but we only use relatively small number of entries in the primary index file. And we know each entry size is much smaller than the record size. look at that kind of compression. Okay, that kind of compression. All right. Yeah. I hope with this diagram, you can understand the structure a little better. Okay. All right. Each disk block usually contains multiple records. We can do the calculation. We need to know the record size, then the block size. Then we do division. We can find that number. How many records are contained in each disk block? Okay, all right. It is called an anchor. Yeah, the first record in each disk block is called anchor record. Okay. A primary index only stores the field values for block anchors. Other records, non-anchor records, so we do not store in the primary index file. Okay, all right. The total number of entries in the primary index is the same as the number of disk blocks in the ordered data file. Ordered number of disk blocks. All yeah, ordered data. Yeah, here this a little confusing. All right, yeah, because we should say original data file. All right, the ordered should be related to the primary index. That's ordered. All right, yeah. The original data file is not ordered. All right, yeah. So that could cause some confusion here. Yeah. All right. Yeah, because the relationship 1-to-1 correspondence. Okay, 1-to-1 correspondence. Yeah. One entry corresponds to one disk block. All right. So that's the primary index. All right. This number is usually smaller than the number of records in the original file. Yeah. Yeah. Much smaller, actually. All right. Yeah. Smaller. Right. All right. Yeah. And later we will do a lot of computation. Yeah. So later we need to do calculation. Yeah. With all the numbers, record size, you know, a lot of information given, then we need to do calculation. Okay, yeah. After we understand these basic concepts, we need to do calculation. All right. Here, performance of primary index. Now we need to calculate how many comparisons we need to do before we can find the target record. Size of a primary index file. How large we can calculate. How large is the primary index file? Okay. There are fewer index entries than there are records in a data file. Yeah. So with a background from previous two slides, we understand this probably easily. Okay. Disk block. One disk block can have many. Here, it's hard to say how many. If your record is not too big, could be hundreds of. You know, if the record is relatively large, then you know, you may not have many records. Yeah. Yeah. Fewer index entries. Each index entry is typically smaller in size than a data record because it has only two fields. Not just two fields, the key value and the pointer usually not very large. All right, yeah, the key value and pointer size usually not very large. Yeah. more index entries than data records can fit in one block. Yeah. How do we store index entries? We also store index entries in disk block. Right? Yeah. Disk blocks, index entries. Hard disk. All the information you store on hard disk must be on disk blocks. Okay. So index entries we also store on disk blocks. Then one disk block can contain much more number of index entries than the number of records in the original data. Okay, yeah. Next, then we can apply the binary search. With these properties, then we apply the binary search. Now, look at how many comparisons we need to make. Performance. This is the function, binary search function. What is that n? This n, number of index entries. Okay. Log of base 2, n plus 1, seeding function, binary search. Okay, yeah. All right, so that's this part. Yeah, I have a few more minutes. Let me see if I can complete the last topic, binary search based index. I just have one slide left, so I hope I complete it. So I do not need to come back again next time. Binary search based indexes. Ordered files. Our index files are ordered files, but our original files are not usually not ordered files. Yeah. So a table can be sorted on some index field. Here the table, that's the original data. All right. Here the table, original data. Okay. In the original data, we sort that table on some index field. We can, but when we store, we do not store the sorted version. All right. We can, but we won't do it in the, normal data storage. We do not store the ordered file. All right. An index file is created and the index entries are sorted in order to apply the binary search. Index, because that's the secondary data file. Okay. And it's the supporting file, and the users do not see them. Usually the users do not know those index files. Yeah. So the DBMS, or we programmers, we create those index files to make the search operations much faster, so we know they exist. All right. So they are ordered files. Otherwise, you cannot apply binary search. Okay. All right. If both the data file and the index file are ordered, that's possible. All right. Because here it considers special case. The original data file is ordered. That's possible, but that's rare. All right. Although it's possible, but it's rare. Okay. Yeah. But even in that case, the index file still faster. The reason is the size. The size is much smaller, right? Think about the size difference. Yeah. If all ordered, both ordered, yeah, that means we can apply binary search on the original data file because it's ordered, right? Even that because our index file much smaller with much fewer entries. If you apply the binary search, it is still faster. Okay. Yeah. So usually the original data file has more fields and contains a larger amount of data. The size is larger. All right. An index file has only 2 fields, key and a pointer. The size is much smaller. All right. A larger file uses more disk blocks. In other words, each disk block contains fewer number of records for the larger files. A smaller file results in fewer disk accesses. Yeah, then it will be faster. We know each disk access is relatively slow. Disk access is relatively slow. All right. Yeah. So we want to reduce the number of disk accesses. Okay. Yeah. All right. Yeah. So that's our last slide. Okay. Yeah. Here we have the basic structure, background information, and later we need this understanding to help us to do calculation. Yeah, we will do many computation questions, but you need to understand why you need to do this way, different ways. So you need this background. Then you know how to do the calculation. All right. All right. So let me stop right here and we complete that part A. Yeah. Because we need to prepare for the midterm homework assignment. Yeah. So we add a few more sessions. Yeah. But at the same time, we need to continue our module 5 and the module 6. All right, so let me stop right here. And next time, all right, yeah, today, yeah, Monday, Monday, I will talk about homework assignment number 2. And Wednesday, we will do the midterm. Part A midterm, 20 questions. All right, so that's it.